and welcome to the math story of Math 1, Unit 2, Linear Equations and Inequalities. I'm Karen McPherson, and I will be your guide on this journey. Throughout middle school, students develop a deeper understanding of algebraic concepts, moving from simple arithmetic operations to more complex algebraic thinking. This work is embedded within contextual real-world situations to support students in developing their conceptual understanding. This progression prepares them for high school mathematics and more advanced mathematical concepts. Let's take a quick look at a few key concepts developed in middle school. In 6th grade, students learn what it means to be a solution to an equation, an essential understanding that will be revisited in this Math 1 unit. They represent relationships using models. This includes hanger diagrams and tape diagrams. Remember that they are working within context of a real-world situation to help them model and make sense of the problem. Students represent the relationships with equations and solve them algebraically using inverse operations. In 7th grade, the relationships become more complex. Students continue to represent relationships using models. They express the relationships with equations. Notice the two types of equations. The differences in these equations provide opportunity to solve using different algebraic strategies. In 8th grade, students deepen their understanding of solving by focusing on the different equations generated during the solving process. This leads them to defining equivalent equations, which is another essential understanding of working with expressions and equations. And this will also be revisited and built upon in this Math 1 unit. Students use the strategy, often referred to as balancing, to solve more complex equations, including those with a variable on both sides and those with rational coefficients. In this Math 1 unit, students will explore another strategy for solving equations, referred to as backtracking. This builds upon the work in 6th grade, where students use inverse operations to solve equations. Students will also deepen their understanding of solving by creating equivalent equations. Solving equations is only one part of this unit, so let's take a look at the unit as a whole. Take a moment to look at the sections of the unit. What do you notice? What do you wonder? The unit begins with writing and modeling with equations. This is where students learn to think of equations as a way to represent constraints or limitations on quantities. This builds the need for being able to solve equations. You may have noticed that the next section, manipulating equations and understanding their structure, is split by the checkpoint lesson. It is in this section where students focus on solving equations. The checkpoint lesson is intentionally placed to provide additional support while working on developing students' procedural fluency. This unit has the first of 4 modeling lessons. Refer to the teacher workbook to learn more about these lessons. The story continues with learning about how to solve linear inequalities in one variable. Then we have the putting it all together and the test and post-test activities. The purpose of the first section is for students to write equations to model relationships. It also includes the lesson presenting the solution strategy of backtracking, which we'll examine closer in just a moment. First, let's look at how writing equations progresses in this unit. Students begin with writing an equation given a verbal description. This activity includes 2 different contexts, so let's just dive into the first one. 4 friends visit a local farmer's market and purchase blueberries. Write an equation to represent each situation. The design of this activity is for students to express the same relationship multiple times, initially using numbers and variables, and later using only variables. Essential understanding in this activity is for students to see that quantities can be known or unknown, and can stay the same or vary, but both kinds of quantities can be expressed with numbers or variables. In the next lesson, students are presented with a table of related quantities, where students may reason with the context. They look for a relationship between the distance from home and distance from school. Students consider operations to connect the two quantities. Since the distances total 400 meters, then the relationship can be expressed by the equation x plus y equals 400. Another activity presents students with a visual pattern and asks about the relationship between the figure number and number of hexagons. There are many ways that students may see the pattern and describe the relationship, thus resulting in different yet equivalent equations. This provides the opportunity for students to build their mathematical practice of looking for and making use of structure. Traditional problem types, such as consecutive integers and perimeter, can be found in the checkpoint lesson as a Desmos activity. In addition to writing equations, this section also includes the solving strategy of backtracking. Backtracking is a strategy that focuses on the order of operations expressed in the equation. Students first describe those operations and create a table that records what to do to the x value. We start with x, we multiply by 4, we subtract 1, divide by 3, add 5, and the result is 2. Next, students build upon the 6th grade strategy of inverse operations. Starting with the result of those operations, identify the inverse operation to undo. Subtract 5, multiply by 3, add 1, divide by 4, and you get the value for x. Completing the inverse operations in reverse order will provide that value. In this next section, students build upon their work with equivalent equations from 8th grade. In this activity, What's Acceptable, students begin with a description of a relationship and its related equation. The purpose of this activity is not to solve the equation, but to understand the moves that create equations with the same solutions and those that do not, such as multiplying both sides by 100, or subtracting $2.70 from both sides. Even combining like terms in the expression on the left will create an equivalent equation. This leads to a public record that students can reference as they continue to work through the unit and solve more complex equations. We refer to this as acceptable moves. This example from the student lesson summary and glossary illustrates how students justify the solution method and each step of the solving process. In the lesson, Which Variable to Solve For, students use various strategies to solve for a given variable. For example, students may use backtracking to solve this equation, a equals b times h divided by 2. They'll create a do and then an undo table, and eventually write h equals 2 times the value of a divided by b. Whereas for this equation, students may use acceptable moves to rewrite this equation for the variable y. They'll subtract the value of ax from both sides, and then divide both sides by b. The last section looks at one variable linear inequality. The approach to solving inequalities is to consider the related equation. Take, for example, this equation, with a solution of x equals 2. Now consider the inequality. The value of 2 establishes a boundary point, which we can mark on the number line. Then students test values on the left and values on the right to determine the solution set. This approach allows students to use backtracking or acceptable moves to solve the equation. The testing of values emphasizes what it means to be a solution to an inequality. Also, a similar approach will be used in the next unit to graph two-variable inequalities. As we wrap up this math story of Unit 2, Linear Equations and Inequalities, let's take a quick look at the public records that will help students track their learning throughout the unit. We have the two public records that look at ways of solving, solved by backtracking and acceptable moves for equivalent equations. And then we highlight how to solve linear inequalities. This concludes the math story of Unit 2, Linear Equations and Inequalities. Thank you for all you do to support students.